Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We have taken the bold, sort of voluptuous step, if you will, into hardware rendering here on Handmade Hero. So we now can actually switch our game between our own software rendering path, where we render all the pixels by our very own hands, which of course is slower because we aren't taking advantage of the giant GPU that's in most machines. But we now also have a path that does take advantage of that GPU, not really to the fullest extent possible, in the sense that we are doing things in not necessarily the most efficient way in there yet, but even so, it is a pretty dramatic increase in the frame time. It's something like 20 times faster on the GPU than it is on the CPU at the moment, for example, if I remember correctly. Maybe not that much, at least 10 times though. And so we made that change, but yesterday we sort of talked a little bit about the fact that there are these extensions in OpenGL, and some of those extensions are extensions we actually need, even if we don't write any shaders, even if we use what is essentially OpenGL 1.x, which is what we're calling right now to render our game. Old OpenGL. Like our OpenGL code right now would run this game on Windows NT 351. The very first version of Windows that's on the kernel branch that we're even talking about would run. That's how old OpenGL we are at the moment. So we would run on literally anything. Like, there is not a piece of graphics hardware or software, because it was software rendered in NT 351, in history that wouldn't render our game right now, as far as I know. But even with that, there is one extension that we needed, or I should say pair of extensions, and that is the fact that our sprites, all of our art assets, are set up specifically to be in sRGB color space. Now, if you don't know what that is, go back and watch those episodes, because it's important to understand why that makes a difference. But point being, we needed to use the extensions to OpenGL to tell it that those were sRGB sprites, or textures, basically, when we use them as textures. Because without that, we get the wrong results for our rendering. Because the color values that OpenGL is using don't mean what it thinks they mean, and then we have a problem. So we needed at least that extension. Now, what we did yesterday is we just kind of threw it in there and used the extension. But we never actually tested technically whether the extension exists. Now, that's probably actually fine, because I don't think there actually is any hardware that any gamer is going to be using today that doesn't have the extensions that we chose to use. But in order to make our code a little bit more correct, and also at the same time to try to set us up for if we do need to legitimately query some extensions a little bit later on, where we really don't know whether the hardware that the person's running on will support them, we want to write a little bit more code to do that checking. And so that's what we're going to do today. And then after that, I don't know, I guess it depends on how long that actually takes us. After that, I'm not sure there's very much left to do with our OpenGL stuff. So I think we might have to wait till next week, because we got to start our next major task, which is getting our texture downloads to happen in the background. Because one of the things that you'll notice right now, since we are just doing a totally hacked thing to test, because remember I said we were just kind of put something in place, when we run our game, you can kind of see that every time, well, I don't know if you can see this on the stream, actually, I don't know how the video it is, but point being, at least when I run it, or if you run the game at home, you can kind of see that when we switch from one when we switch from one cutscene to another cutscene, if that cutscene has like a lot of layers or whatever, it may be the case that we get kind of like a pause in there, right? Where the texture download, there's a little bit of a hiccup. At least I think that was what was happening. I can't quite remember if we actually saw that for reals. We'll see in a second here if we see it. Let's just wait a little bit just to ensure. Let's see here. It probably won't be the one that, like, maybe that hat scene. There'd be quite a few of them. Well, it's not too bad right now, actually. Those downloads seem to be going actually really well, which is nice. Let's see about the hat scene, though, because the hat scene has several layers. I never noticed those little tomatoes back there. I like that basket of tomatoes. Yeah, okay, so you saw it. Hopefully you actually saw it there. You had that really distinct jump. And that's basically like, hey, it had to download just a few too much texture weight, and there, that one as well. So somewhere around, 4 layers or something, when you get to that 4th layer, that's just too much, and you notice that even just in the cutscenes. So let alone in the game where we might be running around and something big pages in or something like this. So we want to figure out how we're going to deal with that part in some way that makes it so that we don't have this risk constantly that we're going to have a frame hiccup because the texture download had a problem. Because in our regular source code, right, we don't have that problem because we do everything on separate threads for asset loading. So the renderer never has to be in this situation where it gets stalled like that. Whee! Sorry, I'm kind of enjoying running around here in our weird little groundless level. Yeah. Yeah. Sorry, I should not be bothering with that. Let's clear this out. There we go. So anyway, that's only going to get worse, by the way, because pretty soon we're going to be working on game code, and I'm going to be sitting there playing the game, and I'm going to forget that I'm supposed to be developing it, and I'm going to be like, oh, it's fun, and then it's like, all right. Sorry about that. So what I was going to say is that's really the big thing, and we have to do it next week. So I'm guessing that today will be a pretty light stream. Maybe there's something else that I should do that we can think of in the meantime, but I don't really know. So I'm just going to go ahead and write that one piece, and if it doesn't happen to take all stream, then we'll figure it out, right? We'll figure it out. We'll figure out something else to do. There's plenty of to-dos, right, that we could do. Maybe there's something simple in there. All right. So hey, hardware acceleration's in there now. And blitz speed improvements we probably don't care about, so I think we're in a pretty good shape now with that. That's kind of nice. There's a couple things in here we probably do want to think about too. With like some of these things are probably worth taking a look at. Anyway, so what I was talking about before, right? We have this Win32 in an OpenGL call, and what I was talking about with the extensions, right, is this part right here. Where we sort of have these extensions that we want to use, we want to enable these, but we don't know whether we can enable them or not. Now, wiggle swap interval, we kind of don't really need to check for. And the reason is because if we get this function back, then we pretty much know that's the only thing it could do. So technically, to be correct OpenGL, I believe you're always supposed to check for the extension string. But really, in practice, we wouldn't have to. But with these, we absolutely do have to. Because we have no idea if the implementation will have any idea what this means, and so I don't even know what could happen. Maybe it's fine to just pass a GL enable that it doesn't understand. Maybe it'll just ignore it. And in that case, even in this case, we probably don't have to actually check for the extensions, but I'm not sure. In general, it probably does seem like if you wanted to rather be safe than sorry, don't call a random driver with a random integer that it doesn't expect, because who knows, maybe the thing just like up and crashes on you because it looks into a table that's not big enough. Who knows what could happen. So yeah, do you need to do it? Could you probably leave it like this? Yes. Will we leave it like this? I think it's probably best not to. So I'm going to go ahead and actually make these things work in some way that's a little bit cleaner than that. So first of all, I'm going to move these guys out of here. I'm going to put these into OpenGL, the OpenGL code, because that seems like a better place for them, right? And then in here, what I'd like to do is say, okay, I'd like to, because these are the same on all platforms, they're not specific to Windows, right? So I'm not going to, that's why I'm not leaving them in the Win32 side of things. And so in here, what I want to do is have something called OpenGL extension is available. But the problem is, what I would like to do is I don't want to keep searching the entire extension string thing every time necessarily. So what I'll probably do is make a little thing here that just allows me to check to see which extensions are available and which ones aren't in just one sort of pass through, right? And yeah, it won't necessarily be it won't be as efficient. It could be even more efficient if we use the hash table or something like this, but it's only a startup, so it's not something that we really want to over-engineer. But what I would like to do is say OpenGL extensions, like this, and then I would like to be able to check for those extensions as we go. So I want to do something where it's like B32, for each of these guys, and I guess I don't remember which extensions these are in, so let's take a look. Let's find out where that is. Oh, wait, sorry, I mean that. You know what I just realized? Oh, right, no, never mind. I was gonna say something and that something was stupid. I was gonna say, you know what I just realized? How come it works when we're passing RGB8 when we're BGR? And the answer is because this is OpenGL's internal requested format, what it's going to store the textures as, not the submission format, and we are correctly passing BGRA for the submission format, so it knows we were passing BGRA data. So it's all good. So yeah, so let's see. Where is that specified? What is the extension for that? Is it this? X texture sRGB decode, I guess. I think that's the one we would presumably want. Let's take a look here. sRGB, does it actually define sRGB8 somewhere? sRGB8. If that texture is applied to a texture, is one of blah blah blah. So is this the one? Is this the actual one that defines it though? This means that the normal linear RGB for shine should create as GLX textures so they can be used with samplers. Yeah. I guess it's this one. Add one new row. All right. So I guess it's this one. I'm not 100% certain. The extension stuff in OpenGL is not bookkeeped as well as I would like, to say the very least. Anyway, we'll do a B32 of that. That's whether or not that is there, right? And then we'll do another one for frame buffer sRGB, and we'll see if that's there as well. So that one is some other extension. ARB frame buffer sRGB, that's that extension. And I guess we want GL ARB frame buffer sRGB because the wiggle one is a given, since obviously if this is there, then we can do the other one, right? So that should be fine. Okay. So what we want to do now is we want to have a thing here, which can do check, OpenGL check extensions. And that seems pretty straightforward, right? And what that's going to do is that's going to just assume that you're in a context right now. So, OpenGL check extensions, so that this can just be called. And then I guess probably what we do is, maybe we'll say OpenGL get extensions or something like this. Maybe we'll do it that way. And then we'll just say like, oh, okay, we'll call that and we can find out what the extensions are, right? And then we'll just say like, okay, whatever those extensions are, will tell us what we wanted to know here. So we'll just be able to say, all right, this X texture decode, if that's on, then we can set our default internal format. Similarly, we got the ARB frame buffer one. So if that's on, we can check it, right? And then that is really, I think, all we would need to do. Let's take a look here. So then we just have to implement something that actually produces this. So we'll start by saying all of the extensions are not available, right? Because that's the default state, is that we don't have any of them. So then what we need to do is we need to ask OpenGL, what are the extensions? Like, what extensions do you support? And the way we do that is there's a GL getString command in OpenGL. Oh wait, we've got that cool doc site that someone sent in. GL getString. So basically in OpenGL, right, we've got this GL getString call, and what we can do is we can call this function GL getString, and it will return like basically a string to us, like so. It will return a string to us, and we can sort of get all of this information that we might want. Now, as you can see, there's actually, the extensions part is only just one of the pieces of information you might want to get. And so while we're at it, I think it might be nice, since these are basically strings that stay around. They're strings that we can use. We could do a thing where we just sort of say in here what all the parts, what are all of the like shading language version. Oops, shading language version. We could just say what all those are so that we always have them around as well in case like we're just curious or we need to print them out or who knows what. Those may come in handy later. So I think what I actually want to do is just save them all. So maybe we'll say OpenGL, OpenGL info maybe, right? And so maybe this way we'll just say, oh, it returns whether the specific extensions that we're looking for are there, but it'll also include some other valuable information because we may want that information for other purposes. So we might as well just do that all in one place since we don't really know what we might need and we're already in a position where it makes sense to get it all at once because it's like that's all the code kind of is in one place and makes sense in a nice way, right? So we'll just go ahead and grab these guys out here and get all the strings and put them back where they belong. There we go. Okay, so we've got all of our strings in there now, and all of these are ones that we don't actually necessarily care about at the moment. In fact, what I can do too, though, is I can sort of show you guys that first. Like we can actually go see what that actually is. What you'll notice here is this one right now we can't actually get. And the reason for that is in OpenGL 2.0 extension, and we're still in OpenGL 1.0. So technically, this guy we can't actually get because, hey, OpenGL doesn't have a shading language. So it's not surprising that you can't ask what it actually is, right? So what I'm going to do here is I'm just going to put that in something where we're just like, you know what, there isn't one. And then we'll continue from there. All right. So here's our info now, and our info, we can use it for these purposes. There we go. And that's get info, oops, get info. And so now when we run this, we should be able to do OpenGL get info and take a look at what it actually says. And this is the first time we've ever done this. Like, I don't even remember what hardware is on this machine, if I ever even looked in the first place. Probably did at some point. But here it is. It's an ATI FirePro V8700. It's running in 3.3 compatibility profile. What that means is the OpenGL version, right, is actually open. It actually supports OpenGL 3.x, right? So in fact, you can see even if you come back here to docs.gl, you can sort of see what that entails, right? So anything where there's a GL3, like active shader program, would not work because it requires 4, but active texture would because that's in 3, right? Or something, right? And here's begin query indexed, only in 4, but begin transform feedback is in 3. So anything that's in 3 would work on this card, right? Far as I know. There may be a couple things that have capability bits to them, but I'm pretty sure that if you're in OpenGL 3.0 core, you have to support them all. If you report that if you're 3, I don't know though. Don't quote me on that. So anyway, there we go. We've got our OpenGL info. We can see some information about the card, and that's great. But now we need to actually figure out what's going on with these extensions. So what I'd like to do here is just say, like, okay, let's loop through these and see what we've actually got. So once we have the extension string, we should be able to do something like, if you remember when we did the stream where I showed how to make a parser, we should be able to do something that basically gives us back one at a time these extensions, and then we can compare them, right? And look to see if they're equal. So what we want to do is do something that like goes through each extension, and it'll do like, you know, if string equals something like this, and I just can look for each of these. And I can probably do something actually like this. If I want to be sort of sly about it. Right? And, you know, we can make as many of those as we want. So that would be pretty straightforward. And you'll notice I just put an if 0 here so that all these cases look the same. I don't know why I did that. I just thought it was nice to have each one look exactly the same. So all we need to do now is have some kind of way of doing string equals. And like I said, we already did this on our parser, right? So when we did the simple preprocessor, for example, we have one here that's like whether a token equals something, right? It was in here, as I thought we did. Maybe I'm wrong. Maybe, there it is. So we're just talking about this code right here, right? This is the exact piece of code that we're talking about. Nothing particularly fancy, but that's what it is. And in fact, this token code is almost exactly what we want, right? Now, I don't know if we want to make this into a general purpose thing. I don't even know. We may already have something like this in Handmade Hero. One of the things that we're not particularly good with on Handmade Hero, and part of this is just the nature of the way that the stream is kind of, I have to be in hour chunks. We don't have a lot of time for like library building where we're like, let's make a good, sensible place for these things to live or whatever. So I don't even know if we've got string equals kind of stuff. If I already have a function like that, I might not. And it looks like maybe I don't at the moment. That's what it kind of looks like to me. So I'm going to go ahead and grab this guy out, and I'm gonna make him actually exist in somewhere here. So I don't know where to put it. Like I said, maybe we've got a handmade string.h. Maybe we'll actually have that. I kind of don't want to because I hope we don't have much. Oh, there we go. Strings are equal. We do have it. It's right there. Yep. No worries. No worries at all. All right, so if I just go ahead and grab this guy, yeah. I feel like if I just grab this guy's thing and I say strings are equal, and then I have an A length, an A, and a B, where maybe the B has an unknown length to it, right? Like that's an ASCII Z string. Then we can go through here and just do it this way. So we say at equals B. We have A length here. That's a UMM, which, by the way, was correctly pointed out that should be a uint pointer. And then in here, we have pretty much the exact code we want. It's just that. And that's the function, right? So this allows us to do a thing where we basically, inside here, go strings are equal. And this is the thing we're checking for, which is an ANSI Z terminated string. And then the other string that we want here is just the like extension count, or like, you know, like maybe we'll just do like count and start, something like that. Count and at, I don't know. Something like this. And so here what we can do is we can get each individual extension and we can process it accordingly. So I'm going to start by saying at equals result.extensions. We're going to do a while loop here, I guess, while at is actually pointing at something valid. Then what I'll do is I'll say, all right, I'll say with the end, it starts at, and it goes until it hits some kind of white space, I guess. In fact, what I probably should do is something like while is white space star at plus at. So skip any white space that might be there. Then I'll say while you know, car end equals out there. Then I'll say while, you know, star end and it's not white space. You know what I'm saying? I'm going to advance end. So it's to scan to the end of it. So now I have like where it starts and where it ends. And so then I can just say like, okay, the count for this guy is just going to be whatever the end is minus whatever the at is. Make sense? And so that's how long the thing is. And the at is exactly what the at should be. So then we can do our comparisons, and then at the end, after we're all done, we can just say, at that point, start at wherever we ended and keep going from there. Make sense? So I'm literally just like picking out strings out of this extension thing, which, by the way, I suppose I never mentioned, so you guys don't actually know why I'm parsing it this way. The extensions that come back is just a giant long, really long string, and each extension name is just stuffed into the string with like a space in between it. So you'll see in a second. So really all we need here is the white space part of it, and I don't know if we've got a white space tester. We do. So we'll put that in there as well. In fact, I don't know, we might want more of these eventually, but okay, so anyway, in handmade.h, I don't think we have an is white space. Yeah, we don't, so we do now. And so end of line we also need, because those depend on each other, it looks like. There we go. And we can sort of deboolify those, like so. All right. So inside Handmade OpenGL, that stuff is in what, handmade.h, which I don't think is actually installed here. So what I probably want to do is put these somewhere where they can be reached as like a common place. So maybe the platform where we have some of these like little handy functions here. Those can sort of get thrown in there, maybe down in here. Okay. Oh, that gets me every time. I keep forgetting that we decided to make this C linkable for people who are reporting to other platforms. So I kind of need like a shared library place. I need like a handmade shared.h or something like this, right? Something that we know gets included in everything. And I'm not sure what just happened. Why is handmade shared.h not a C++ mode thing? I don't even want to know. You know what? I don't want to know. Handmade shared.h. There we go. Okay. So I just kind of need some place to stick this stuff. I feel like that's going to be included in both places, right? So handmade.h, right? It can include this stuff, and then we can start sticking things in there that make some sense. So it's like handmade shared.h. It's in there, but then it's also in like Win32 handmade.h. It's also in here. Does that make sense? Probably after intrinsics. In fact, intrinsics and math could actually be included inside this. So it could be something like this even, right? And that way in here, we just assume that those are going to work that way, right? Okay. Let's see, where are we here? Gotta put some parentheses in there. All right, so let's go ahead and go a little further with this and try to get this working. So let me just show you, before I go any further with the programming, I just wanted to show you guys what I meant about that extension string. So here's the extension string. And as you can see, it's just a giant old mess. But basically what it is the extensions are just every extension name that this particular graphics, with this particular OpenGL implementation supports, is stuffed in here somewhere. So you can even see, like, here is the one that we wanted, glx frame buffer sRGB, right? That happens to be one that we're looking for. GLARB, oh, sorry, no, that's the X one. We were looking for the ARB one. Maybe we should look for the X one, actually. But there's GLARB frame buffer sRGB right there. So both of those are listed as being exported. Maybe we should use the Xed one because the Xed one probably is even older, right? And it would support more cards. I don't know which one we want there. But then there's X texture sRGB decode, and that should be in here as well, I would think. sRGB. So it looks like that's actually called X texture sRGB, not decode. So the decode one is probably a different one. This is why I was saying I was having trouble figuring out which one it was supposed to be. So I think we actually want it to be this. I think I just was asleep at the switch there. I think that's what we actually want. And I just don't know. I suspect we probably want, my guess is we probably want the X texture RGB, because that's probably the one that's further back, if that makes sense. Let's just find out. So let's see. Oops, I meant frame buffer. Where'd that guy go? GLX frame buffer sRGB. So yeah. So if we use this one instead of the ARB one, the Xed ones come first before they get promoted to ARB extensions, like I mentioned on the previous stream. So that one might actually have more support for it further back. Now, probably it won't matter, like I said, because these are extensions that almost every graphics card probably has now, I suspect. But point being, you know, if we're being proper about it, which we're trying to be, then that is just the way that is. So let's go ahead and put this in here, and then we'll take a look. So what I'd also like to do is verify that they're the same ID. So I'd like to verify that they're the same here. So I'd like to figure out what GL frame buffer sRGB is defined to in this extension, if we can, which I don't know if we can or not. So let's see, is it 8DB9? Yes. So there it is, right? So that's what we want. And it's frame buffer sRGB Xed is the name of it, which I don't know if we actually need to change it, but that should be fine. All right, so that all looks reasonable now to me, but now we still have to actually implement this code for actually checking the extensions. So let's go ahead and recompile this guy here. Oops, gotta put a B32 on there. And this is that one, and this is that one. So anyway, if I run through here now and I get to my extensions, so now I'm just gonna like get this parser working. So let's see, so there's we skip the white space, which in this case there isn't any. We take a look at where the end is, and let's see, that should point to the space, that next space there, and it does, which is exactly what we want. Let's look at the count. The count is 14, but that's 14 hex. The count is actually 20. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Exactly what we want. Let's see about strings are equal. We'll call those. We then do add equals end, and we start here. So now we come through and we're at white space, so we skip the white space, and we keep going. Okay. So that all seems pretty good. And let's see if we actually correctly identified these guys. It looks like we did in both cases. So I think we're all good. I think we've got a parser now that actually works. Okay, so that's the extension parsing in a nutshell. Yeah, we got a ton of time left though. I mean, honestly, we've got like 20 or 25 minutes left. So I guess, yeah. I guess we're going to have to do something else that will take about 20 minutes because there ain't much more to say about extensions that I didn't just do. So we can get rid of our to-do. That's all good. And, you know, I guess one of the things we could do here is inside Handmade OpenGL, we could actually we could actually make this be a more common thing because we could do something like OpenGL startup or something like this, or OpenGL initialization or whatever. And this part is going to be common, right, across all of our platforms, because we're going to want to check for these same extensions. We're going to want to use all this stuff. So what we could do is just say, hey, everyone can call that. And the only thing that the platform needs to do is anything that's specific to it, like this wiggle swap interval part of it, right? So that seems probably like a more sane thing to do at that point. Yeah. That's what I think. So, yeah, that's it for that. And I'm not sure what else we would do with OpenGL here that would only take 20 minutes. That's kind of a tricky question. So, well, we could try to put in buffers. I don't know that buffers will make any difference here because the texture changes are going to be the thing. That's going to be problematic there. So, yeah. Maybe we could try, maybe while we're in the middle of implementing, maybe while we're implementing extensions, you know what we should do? Because this is probably going to be important for our texture downloads. What we should probably do is show how to do context escalation. That's probably the most sensible thing to do. All right. So I talked about this a little bit before, but I'll just say it again. So OpenGL has gone through many revisions, obviously, in its history, and you sort of have seen a little bit of how that works. And I explained it a little bit more detail, so go back and watch yesterday's episode, I think is where we talked about this. But I'll just say it again. What happens in OpenGL is the initial version that shipped with Windows was OpenGL 1.x. I can't remember exactly which one. It was like 1.1 or something like this. Maybe it was 1.2. And then, as it went, OpenGL has evolved away from there, but Microsoft never bothered to update the bindings in Windows at all, and they never bothered to require a newer version of OpenGL. So, you can still ship an OpenGL 1.x driver if you want. And the reason for that, of course, is that they want DirectX to be the primary graphics thing, so that any chance they get, they try to make OpenGL less attractive. That's just, and again, that's not me being flippant. I know lots of inside information about those things, and they really are exactly that awful there. So basically what happens is all of the OpenGL progress comes from the driver manufacturers, for the most part. And Microsoft gets dragged along kicking and screaming with that. And so what happens is the driver writers themselves are the people who are updating OpenGL, right? So when you actually pound include gl.h, like we did to access the Windows GL bindings, you're really including what amounts to a decade or two old set of bindings. And everything else that has come since then, you have to get by querying and using these extensions. Now, extensions are an actual first-class citizen in OpenGL in the sense that it's meant to be extended. And vendors are allowed to add their own extensions, so they add these extensions, but over time the extensions get sort of agreed upon as generally useful things. And when they agree that a bunch of these extensions is going to become sort of a new version of OpenGL, they update the core version number. So it becomes OpenGL 2.1, OpenGL 2.2, OpenGL 3.0, OpenGL 4.0, whatever, right? And so what they did with OpenGL 4.0, actually, to be honest, I think they may have done this in 3.0. I can't quite remember when they introduced this. OpenGL 2 didn't have it, but OpenGL 3 maybe had it. What they did is they said, okay, OpenGL 3 adds a ton of stuff mandatorily. Like, OpenGL 3 requires that you have a certain set of shading languages available and certain shader stages and all this stuff. So OpenGL 3.0 requires a bunch of stuff. OpenGL 4.0 requires a bunch of stuff, which means that you don't have to query each extension piecemeal to find out what you can use. You can just say, are you OpenGL 3? If you are, I just assume that you have all this stuff and you better run it, right? So OpenGL 3 there's a way we can query for an OpenGL3 context. And that OpenGL3 context, if we get it, we know that we have everything that we might need. And since almost everything that you're going to run on these days is an OpenGL3 context or above, that's a pretty good idea. Do we need to do it? Not necessarily. But that same process that allows you to query for a more modern whole context rather than querying extensions piecemeal, that exact process actually allows you other options that you don't have when you normally create a context. One of which being the ability to create more than one context so that you can use it on multiple threads and still have them share texture handles. And so what you can do with that is you can actually use that to, say, download textures on one thread while you run the game and render on another thread without those contexts fighting each other. Because I believe the actual requirement in OpenGL is that you are not allowed to use the same context on two threads at the same time. It's single-threaded that way. So if you want to use a context in two different threads, you actually have to make two different contexts. But if we make two contexts and we start sending textures down on one context and rendering on the other, if we have no way of telling OpenGL that they're sharing their texture handles, there's no way to actually benefit from that. Now, there are some ways you could do that in the old days, but it was all kind of a hack. And so what I'd like to do is go ahead and use the actual context escalation stuff to sort of show how we get one of those OpenGL3 contexts, and then we can use that when we need to, next week, finish off our base implementation of hardware acceleration by downloading textures in the background on a separate thread that isn't the main thread, just like we were loading our assets. So that's what we want to do, right? Okay, so let's do that. This is a Win32 situation, obviously, because when we create the context, we're in Win32. When we do wiggle create context, now this is going to look like it's pure banana cakes. Again, like I said, this is because hardware vendors don't have a lot of choices. Microsoft doesn't really help them out here, so I don't really know that you can blame NVIDIA or ATI for this sort of thing. I'm sorry, AMD. But when you call wiggle create context, as you can see, takes no actual parameters, right? It just creates a context. So by default, what it does is it creates a context that's only requirement is that it at least support OpenGL like 1.1, or like I said, whatever that first version is that ships in here, okay? So OpenGL like 1.1 or whatever is what it will give us back. If it has the capability of doing more, it will give us back more, potentially, right? But we're not asking to require that. So everything that we might want to use, we have to query as extensions, and that's just the name of the game, right? Okay. However, what you can do is use an extended OpenGL function. Again, like I said, everything's extensions because it has to be. And it's called arb create context. And what that extension does is it allows you to call a new thing where instead of just asking for a context in general that's arbitrary, what you can do instead is request a specific set of features for your context that it must have. And those are set, I don't even know where they're listed here. Here they are. You can require a specific major version, a specific minor version, certain other aspects, like for example, there's a bunch of flags we could set, and those are like whether we want them to be debug compatible, whether we want them to be forward compatible, right? Whether we want them to be core compatible, things like this can be set in here. And these are basically things which control what kind of context we expect to get back. So if we want to do this, what we need to do is get a handle to this wiggle create context attribs function, and then we need to call it, okay? And we've already seen exactly how to do this, so this should not be a mystery to you. We already know exactly how it works. It's the same as what happens here, right? All we need to make this happen is a type def of what we expect the function signature to be so that C knows how to call it, and then we need just somewhere to put it. We don't really need to keep it in a global variable because we're never going to call this function other than at startup time. So we can just say that it's wiggle context attribs arb that we call once, right? So we can take this guy and we can call them just one time. All right. So let's go ahead and do that. Remember, like I said, this is totally this is exactly just going to do the same exact thing we already did. So there's absolutely nothing bizarre going on here. You can see how we did this wheel-get-proc address. We're going to do that exact same thing. So here we are. Only I'm going to put this above the init, actually. So we can do this wheel create context of tribs arb. We can say, hey, let's see whether or not this thing exists. So I'll say, again, exactly the same thing as here. No change. The only difference is now we're going to use wheel create context arb as the function. If that comes back, then we now know that we are in, this is, or I should say, a modern version of OpenGL, whereas here it would be, this is an antiquated version of OpenGL. Okay. So in the modern version of OpenGL, what we can now do is we can call this function to get what we actually want. And again, we pass basically the same things. We pass window DC, we do a share context, right? And a share context is actually pretty important. We don't need to use it yet, if that makes sense. And the reason we don't need to use it yet is because, like I said, we're not actually creating a second context for texture downloads. But that's exactly what that's going to do. Like, what we can do now in a way that we couldn't before when we created context is pass some other context that we want to be able to share all of our data with, which is exactly what I said we wanted and the whole reason why we probably really want to use the modern contexts, right? So we don't actually need the share context, that's fine, but we do need those attribs, and those attribs are basically just like a list of pointers to ints, right? So it's basically this. Just a big old list of ints. And then the ints describe what actually has to happen. Now we need all of these guys, right? We need all of these guys to be defined, and they're not defined right now. And so what we want to do is in OpenGL, in our OpenGL thing, we want it sort of a window-specific area. And we don't have to isolate these. These don't have to be isolated because there's no harm in defining the Windows things here, right? We can define the Windows ones here, the Apple ones here. We can define everything here because they're just pound defines that are just generally true. And we just would never touch them. We never actually use those, right, on other platforms. So that's totally fine. So then in this attribs, these come in pairs, right? So we can say is like, oh, we want a major version. We'd like our major version to be at least 3. We want our minor version to at least be 4. I don't know what a layer plane arb even is, so I'm going to look that up because I don't think I've ever asked for that. The layer plane that the rendering context is bound to, the attribute value has the same meaning and allowed values as the layer plane parameter of will create layer context. What is this? I don't even know what that is. It looks like it's just if I have a display that supports multiple planes that are maybe recombined at hardware time. Yes, this is just for overlays, which we don't care about at all. So we don't even need to specify that, I don't think. We can just skip that bit entirely. So what we need are flags, though. Let's put some flags in there. Oops. Let's put some flags in there. Our flags are whether we want debugging and whether we want forward compatibility. I assume forward compatibility means should you give us access to more stuff. I think the answer there is probably always yes. And do we want debug? Well, probably if we're in debug mode, we would want debug, right? So probably we'd want something like, we'll always take forward compatibility if you've got it. And then maybe we'll do this, or maybe we won't, right? So we could do something like handmade internal. We'll ask for a debug guy, otherwise not, probably, right? And then we've got our profile mask. And the profile mask is just specified as whether we want core or compatibility. Right now, we're going to want compatibility. And the reason for that is because technically the functions that we used, like if we go over here to our handmade OpenGL.cp. The fixed function pipeline, remember I said we're going to start with a fixed function pipeline, which I showed you here. The fixed function pipeline doesn't exist in modern versions of OpenGL. They got rid of it. Everything goes through shaders, so you have to just write dummy shaders if all you wanted was the fixed function stuff. You still have to write little dummy shaders that just don't do anything, but they still have to be there, right? And so we want a compatibility profile, because what that says is, hey, don't give me only the 3.0 stuff, give me the old stuff as well so I can use it. Now that's not guaranteed to succeed. A implementation doesn't have to support the old things, which is why I said eventually we want to just move away from it and not call the fixed function anymore. I just wanted to show you how to do that because that was the original OpenGL. In the modern OpenGL, it's really not that much different. It's, you can still understand it pretty easily if you see this stuff. But again, some of this stuff goes away. We'll want to remove that as we move to shaders, which we want to do anyway because we're going to have a couple of special effectsy kind of things that probably want the ability to reach in there and muck with exactly what's happening in the shaders. We would probably not want the fixed function pipeline to be the only thing we have access to anyway. So that's not a hassle in any way. We would have had to do that work regardless, if that makes sense. It's just one step at a time. So I think this is everything. I believe the way you end this is by terminating it with a 0. But let me see. The list consists of a sequence of name value pairs terminated by the value 0. So that's what we want. So there's our attributes. Here's our context call. And here's our modern context. And then in here we can say, like, okay, if we were able to get a modern context, then let's go ahead and switch to the modern context. Right? And we can even delete our old context. Right? We can get rid of our OpenGL RC. Right? So we can just straight up swap them. And so this is why I called it, you'll notice the thing that I said originally was I was like, hey, it's like escalation. The reason I called it context escalation was specifically because in order to call wiggle get proc address, you had to have created a context first. You can't actually call wiggle create context attribs arb until you've made an existing OpenGL context of version 1. So you basically have to like say, I'm starting my OpenGL stuff so that the driver can get up and going. Then you say, hey, by the way, are you a new one? I know like Microsoft doesn't want OpenGL to succeed, so they didn't actually bother to make a good way to do that. But hey, could you give one to me? And they're like, yes, right? And so you do that, and then you try to create one. If it succeeds, now you can switch up to the modern version. Make sense? So that's how you do that. Oops, that's an S64. That's how you do that. And so let's see if it works, right? Because again, like I said, all this stuff is kind of a little touchy, so maybe I forgot something. You'll note I do all this stuff kind of from memory, and I'm old. So anyway, where is my OpenGL? Win32 init OpenGL, here it is. So here we go, let's step in here. And we're going to ask to see if we can get our context attrib arb function. You can notice that we did get that, right? And I'd point out something else interesting about this, because this is some stuff that people were sort of asking about the drivers too. Oops, that's not what I wanted. So you can see, if we inspect this value, note where it's pointing. It's pointing into the ATI driver, right? So when we are making these function calls, we're not going into a library, right? This is what I was kind of trying to explain before. When you link with the OpenGL library, you're not really linking with a library. You're just connecting yourself with the actual driver that's doing the work, right? That's actually what's happening. And so in this case, we've asked for a function, and now we're basically calling directly into it, because unlike when we link with a library and it uses an actual import table, we're actually getting the thing back directly ourselves, and so now we call into it via a pointer instead of it patching up our code, right? So we get that. Now we know we can call it. So we create our list of attribs, which is everything that we might want there. And then we come through and we can call create context attribs arb. You can notice that took a while. That's because now the ATI driver is going off going, oh, okay, all right, let me get all that stuff set up for you. And then we got back a context. So it worked. So that's good. Which means we can escalate. We're now on OpenGL 3.0, which is fine. We can delete our old context, and off we go. So now we're actually running in OpenGL 3.0. What that means is that these are actually superfluous calls because I believe all this stuff is required in OpenGL 3.0. I don't think you can. We don't really need to check extensions, but we might as well because this allows us to run on older hardware even than 3.0 if we wanted to. So there's no real reason to get rid of it, right? It just gives us an extra layer potentially of backwards compatibility. So yeah. Unfortunately, from what I can see here, when we're on the modern 3.0, it looks like it doesn't want to let us use the old compatibility stuff, right? It looks like we're not getting any rendering there. And the only difference was that we asked for a 3.0 context. So I'm guessing that we didn't actually get back a compatibility profile, maybe? We asked for one. We asked for one right here. But we didn't get one. I'm curious to know. I want to try without this guy. But I'm curious to know why that didn't work. But we're doing something that the 3.0 context doesn't like, right? So okay, so it's the forward compatible bit. Let me go read what that does. I must have misunderstood what the forward compatible bit is. It probably prevents you from doing anything that's going to get removed or something like that. Let's take a look. So there it is. If the wiggle context forward compatible bit arb is set in wiggle context flags arb, then a forward compatible context will be created. Forward compatible contexts are defined only for OpenGL version 3.0 and later. They must not support functionality marked as deprecated. Okay. So basically what we want to do is we don't want to actually specify this. Probably at all, actually. But we might want to do it for testing, right? If that makes sense. So I think that's everything we want to do. So I'm going to go ahead and call that the end of the stream. Because now we have that profile. And so now once you have that, this means you can use shaders. You don't have to query even any extensions for them. You can just straight up use shaders, and that will tell you what's going on. Now, what also will work there as well is we could now, if we wanted to, we could query the shading language version as well. The only problem is we have to go define that string. We have to define GL shading language version. And we could actually do that now, right? So we could say, let's see where that's actually defined, somewhere. I don't know where. I have no idea where. Tell me what the value is. OX something. Fine. I did this the other time. I'll do it again. Where did I had it the other day. OpenGL extensions header file. Where did it go? Because it's in one of the. It was in one of these, but I jumped right to it before, and now it's like Mr. doesn't want to do that for me. There it is. Core arb shading language version. And so the question that I have, and I don't really know if it's true or not, but I guess we don't want to do this unless we know for sure that we've got a more modern context, right? So what I might say is inside here, right, we'll define this guy, GL shading language version. so that we can call this, but maybe what I'll do is something like this. So that I know that I'm only asking, because I don't know which versions that would be allowed. We could query an extension for it and then ask, but I feel like this is probably safer, right? And maybe I'll do a thing where we just say modern context is actually in here as well. So that way we'll say that this will be something we actually pass through. Right? And we could add another layer of security here, potentially. Something like this, just in case that fails. We could do it only if that actually worked. OpenGL get info actually needs to pass this. Modern context. And so now we should be able to see the shading language version as well. So when we jump in here, at least in theory, when we call that, our result is going to tell us. So OpenGL 3.3 is the latest, GLSL 3.3 is the latest shading language we'd be allowed to use, right? There's later shading languages. There's a shading language 4, and we can't call it on this graphics card because this graphics card is from like 2010. It's pretty old at this point. So there you go. That's it. That's how you do that startup. So hopefully now everyone's got that under their belt and is happy and great. And so we can go to the Q&A for a little while. We got about 12 to 11 minutes left. So if you got questions, let me know what they are. Icarus, looking at WinXP and cards, looks like they need GL 2.0 as the max they can support, more or less, if you use ERA cards. Yeah, I would suspect. I mean, going, like I said, back all the way, GL 1.0, I think, or maybe 1.1, something like that, was what was originally in Windows. By the time WinXP came around, I'd be pretty surprised if there was anyone who wasn't at least 2.0. But I don't know. In the function OpenGL getInfo, why did you do an if zero else end if rather than just commenting it out? I'm not sure what you're talking about. Do you mean this thing? It was because I wanted to keep both cases, and for the very specific reason of, as you noticed, I eventually turned it into a real if. Is that what you're talking about? Not sure. Let's see. Insofar as for sRGB, do you also have to set wiggle frame buffer sRGB capable ARB when you choose the pixel format, or is that something different? You know, I had that exact same question, and I do not remember. I really don't know. And the documentation is so crappy. Like, that should be pretty much obvious whether you have to do that or not. But unfortunately, it's like not that obvious. So we could try to figure it out. Obviously, it's pretty easy for us to set that, but capable ARB. Let's see. Yeah. This guy is pretty uninspiring as a actually, that's not what I want. I want wiggle frame buffer sRGB Accepted by the PI attributes parameter of wiggle get pixel format attrib vx wiggle choose pixel format ext. Accepted by the cap parameter. So if we wanted to call wiggle choose pixel format ext, maybe that would be the place where we could do that. So here's wiggle x pixel format. This essentially adds functions to query pixel format attributes and to choose from the list of pixel formats supported by a device. So here's some extra ones that allow us to say other things. So like, yeah, you can see there's a bunch of stuff. Overlays, underlays, swap methods. So the question is, do we need it? And I don't know. I'm not sure. Let's see. Components. Let's see. The stage buffer components are taken to be fixed point values. Yep. If frame buffer sRGB is enabled and the value of frame buffer attachment color encoding for the frame buffer attachment corresponding to the color source sRGB. So I'm going to have to say, possibly yes, based on that sentence. Because the way I read that is saying that if frame buffer sRGB is on, only if the actual frame buffer that you're using is marked as sRGB. And ours won't be unless we specify that. Which would mean, I think, in order to get it actually working, which we think we do want to do, because our textures will be right, but our frame buffer would still be potentially wrong. Wait. The thing is, I guess, well, no, we want, it basically just gives us another level of accuracy, right? Instead of treating the frame buffer as linear all the time, so around the alpha edges, it's going to be really subtle, but it would matter. It would actually matter. So I think what we would want to do is we'd have to do the wiggle, the extended pixel format, right? We want wiggle choose pixel format, something like this, right? I think we'd want to actually call wiggle choose pixel format arb, and I think we want to do it. So maybe we want to do that on Monday, because yeah, I think the only way we can actually ask for that is through this. I don't think we could set it using the choose pixel function that we're currently using. Maybe I'll add a to do, because I do think we want that. And it does sound like from reading the extension that it won't work. That's just what it sounds like. Maybe I should put a question mark because I guess we're not really so sure about that. Let's see. Kalimian, from Connor Rentz, who just left, what is UMM data type and what is it used for? I will watch this recording. That is just an unsigned, memory-sized integer. So it's basically like 64-bit on a platform that's 64-bit pointers, 32-bit unsigned on a platform that's 32-bit pointers. So it's uint pointer t. Raul, yes, that's what I was talking about. I didn't notice you did more there. Okay. Sinocron, what's the difference between sRGB and RGBA? That is covered in a lot of detail back in the previous stream. So I would I'd watch the streams on sRGB encoding. Well, to be honest, I don't know that we really covered it all that thoroughly. We covered gamma correction, and that's what it is. But sRGB is a particular color space, right? So sRGB is a color space. And it's a color space that has a particular gamma curve that's like, it's like 2.2, I think it's like 2.2 gamma curve. So it's like, it's whatever the color is. It's raised to the 2.2 power everywhere except down at the bottom where it's not, where it's linearized out in a particular way. I don't remember the exact specifics, but it's the one that Adobe proposed, and it's the kind of the prevalent one that graphics cards implement. And you can kind of see here, let's see, where's the actual curve? I don't actually want perceived intensities. I just wanted the actual curve. I like, what is sRGB and why is it so important for e-commerce? I was like, okay, I don't know that I would have thought it was that important for e-commerce, but I guess it is. I'm always bad at finding graphs on the stream. I don't know where it is. But point being, there it is. This is the image I think I wanted. There we go. So point being, as you can see, it's pretty close to just 2.2, but it's not exactly the same. And why it's not the same, I do not remember. It's some finicky reason, like it wanted to be more well-behaved numerically at the bottom or something like this. So it's basically the same gamma curve as a monitor was with the 2.2 standard way that they used to be, but it's a little bit different. And now all monitors have an sRGB mode that you should set your monitor to, by the way. That's that curve. So anyway, sRGB is just that encoding, and so it's a way of encoding colors, color values, such that they more closely put the detail, like where they put the resolution of the color space where your eye can see it, rather than where it can't. And so what happens with a gamma curve, right, is if you imagine a linear brightness response. So here is like the input color value. Here's like the color value from 0 to 255 that we might specify like in the game, right? Or 0 to 1.0 if you're in floating point, right? And here is the brightness that the monitor outputs. If that makes sense. If you're linearly outputting brightness, then what happens is you end up with the resolution in the wrong places, because your eye up here is really bad at perceiving the difference between brightnesses. So like bright is hard to discern. The difference between a point here and a point here for your eye to discern in terms of brightness, it's hard for it to tell, right? However, down here in the dark areas, it's easy to discern. So if you have a point here and a point here, your eye can very easily tell them apart. So what that means is if you, for any given encoding them linearly means either you'll have way more sort of resolution in the brights than you want in order to get the resolution in the dark that you need, or if the brights are roughly how much you need, the darks will be way underrepresented and you won't have enough resolution. So the solution to that is to use a curve so that as you go from 0 to 255 or 0 to 1, depending on which one you're doing, as you go through that curve, you have lots of values down in the darks, right? Because you notice the same number of dark values output to a very small range of brightnesses. And then you have very few values up in the brights. So like, 5 steps up in the brights might account to like some big area here, whereas 5 steps up in the darks accounts for only a very small area here. So that it's basically just bending that curve to give you the output resolution where you actually want it, so that you don't have to transfer 16-bit color, for example, per channel, 16 bits per channel, to get the resolution. You can just use 8 bits per channel, which is really actually kind of important, because even today, right, 4K monitors, you have to go to HDMI 2.0 just to get 60 frames a second on those, right? I think, can you even? I don't even know if you can. I think that can do it. But point being, all that stuff, like the cable quality and the HDMI specs and all this stuff, those are all fighting to give you enough bandwidth to the monitor, right, to actually be able to run games at high res at high frame rates. And if you start throwing away that bandwidth there by saying, okay, now we got to have 16 bits of color to represent what we need to represent or something, right? You're totally ruining your ability to get high res, high frame rate, because you're wasting it all on these extra bits that you didn't really need if you just had a smarter encoding. So that's why you need these gamma-aware encodings. That's not to say that 8 bits is really enough. Even with a gamma encoding, you probably want more like 10 bits or something, I'm guessing. Maybe even more as displays become more high dynamic range. You maybe need even more like 12 bits or 14 bits, who knows, right? But point being, no matter how many bits you use, even if you use that many bits, you want to maximize that value per bit by putting the curve to align with your eye's perceptual ability so that you're not throwing away bits on the high end or having too few bits on the low end. Let me just check to see if there's any other questions before I sign off. Any other questions that like need to be answered, that are pressing? Pressing. I just checked my Dell monitor. It has Adobe RGB as well as sRGB modes, and they look fairly different. So what's the better one? Well, that just depends on what you're displaying. sRGB is the best one for games because that's what games will use. Adobe RGB might be the one that has the really weird, crazy multi-part function. I don't remember. There's this one that's like super weird. Where's the equation? Show me the equation. Oh, no, this is not. So this is not good at all. You definitely don't want this. Never mind. At least I don't think so. You know what? I'll be honest. I'm the wrong one to ask. I'm so not a color space knowledgeable person. So this is the 2-part one. This is the one I was thinking of. I think this is the one you want. That's certainly the one that I think the graphics cards implement. That was my recollection. So I think that's the one you typically want to set to. Orlando Bloom, I've heard a lot of monitors aren't even really 32-bit color, sometimes less with dithering in the monitor. Yeah, I think that's actually possibly true. Because since it's never been one of those specs, like basically, a lot of other things have been specs that people have hyped on like TVs and stuff or whatever. It's like 60 frames a second or 120 frames a second or whatever. They start hyping them and then TVs like have them, whatever they are. Whereas bits of color, people have not like pushed yet as a thing. So yeah, you end up with people cutting corners so they can sell a cheaper TV that still looks like it has the same specs. Anyway, I'm a shut down now. Yeah. There we go. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. And it's been a fun week. We added OpenGL rendering to our game, which is kind of fun. And now we have access to a heck of a lot of computing power in there for doing our rendering, which is kind of nice. The CPU was pretty good at rendering, but of course the graphics card, which is totally made for it, is better. So, that's it for today. If you want to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code, so you can play around with it even as we speak. I upload it every night after we're done here, so you can play around with it and experiment if you would like to do so. We also have a forum site if you want to go ask questions. We have a Patreon page where you can support the video series if you are so inclined, and we also have a tweet bot that tweets the schedule at you. So if you want to catch the stream live, that's the place to do it. We will be back here next week, I suspect, unless for some reason we're off. So definitely check the tweet bot for information about that. Until then, have fun programming, guys, and I will see you all on the internet. Take it easy, everyone.